Alright, so today we're going to be talking about imaginary numbers. Basically, we talked for the last couple of days about solving equations either by factoring, using your graphing calculator, or solving by square roots. But all quadratic equations should have two solutions. A quadratic equation, remember, is ax squared plus bx plus c, and it either says equals 0, y equals, f of x equals, something like that. Well, either you're going to have both solutions being real, which is what you've done up to this point, but starting today, you can have both of the solutions be imaginary. The easiest way to visualize this is if you took a parabola, our solutions are the same as our x-intercepts. So you know that if you can see two x-intercepts, these are both real. So this has two real solutions. In this parabola, notice that it never crosses the x-axis. So there are no real solutions. And now we're going to assign values to those unreal solutions, and they're going to be called imaginary solutions. All right, so mathematicians didn't like the fact that you didn't have an answer, so they created a system that's based upon an imaginary unit, which is called I. It's easy to remember, I and imaginary. So the definition of I is that it's the square root of -1. They said let any square root of a -1 be I, and using that we can simplify any numbers. We can square it and call I squared equal to -1, which we're going to use by substituting. So anytime that you see I squared, you're going to replace it with -1. Okay, if you're simplifying radicals, we're going to use this concept of I equaling the square root of -1. Okay, so normally you would say, well, the square root of -49, it would say it's a non-real answer. And up to this point, you always say, okay, well, I don't have a solution. So if you remember that -49 could be rewritten as -1 times +49, then we know that the square root of 49 is 7. The square root of -1, this is our brand new definition. That's equal to I. So this is really 7i. One thing you could do is you can set your calculator to be imaginary mode. So go to mode, and then down here, instead of just real, we have the a plus bi setting. So if I do square root of -49, there's your 7i. So you're welcome to use it on your calculator if you'd like. All right, so on this problem, I'm going to replace -16 with square root of -1 times +16. This is my imaginary unit, and this is square root of 16, and I have a 2 out in front. So now I have all i's in there, and what's the square root of 16? That's 4. So 2 times I times 4, that's 8i. All right, and then this last one, we have -1 times 18. That's the same thing as -18. So just basically simplify this like you would normally. So from yesterday, we think of what's a perfect square that goes into 18, 9 and 2. Square root of 9 is 3. This is radical 2. And then because of this -1, you're taking the square root of that. That's I. You can just say 3i root 2. Notice there's no pluses or minuses here. We're not solving an equation, so you shouldn't have two solutions here. It's only when you get to these problems, this is where you have to have two solutions. So anything where there's an equal sign, that's where you have two solutions. When there's no equal sign, you just get what you get. All right, number 4, we're simplifying. So all this is combining of like terms, multiplying, distributing. Pretend that the I is just a variable. It's technically a number. It's not really a variable, but we'll just act like it's an x. So if I want to add two things together, I look for like terms. 5 plus 6 is 11. And then 3i and 2i is 5i. All right, now typically with x's, you put the x first and the number second, but with this, we kind of put it in a plus bi form. So the real part goes first, and the imaginary part goes second. All right, with number 5, we're subtracting. So I'm going to distribute -4 minus 5i. And then I just look for my like terms. So 3 plus -4 is -1. -7i plus -5i is -12i. If you really want to, you could do negative 7i minus 5i, and that's negative 12i. Right? But I think you can add negative 7 plus negative 5 and know that that's negative 12i. All right, one more negative that I need to distribute. So negative 5 minus 6i, and then combine your like terms. So 2 minus 5 is negative 3. I minus 6i is negative 5i. And then I'd like to double check that it's in the right order. So negative 3 comes first and negative 5i comes second. This one's multiplication, so it's a little different. We're going to distribute. 3 times 5 is 15i. 3i times negative 3i is negative 9i squared. So this is where you have to go back and look at a definition of I squared is negative 1. So we never want to leave an I squared in your answer. If you ever see that, that's the same as negative 1. So we have 15i minus 9 times negative 1. So 15i plus 9, because negative 9 times negative 1 is plus 9. This answer is okay, but I'd rather write it in a plus bi form, so I have 9 plus 15i as my final answer. Okay, so we're going to keep going. We're going to multiply, right? So the easiest way to do this is like think of double distributing. So I'm going to do first times first, outer times outer, inner times inner, and last times last. So 2 times 4i is 8i. Sorry, 2 times 3 is 6. Then I've got 8i. Then I have 9i. And then I have plus 12i squared. Right? You can think of it as double distributing or the FOIL method. Okay. Now anywhere I have an I squared, that needs to be replaced with negative 1. So 12 times negative 1 is negative 12. If I have like terms, just like anything else with like terms, I would combine those. So we have 17i and we have 6. Well, now I have 6 minus 12. That's negative 6 plus 17i. So your final answer should have numbers or i's and nothing else. You should never have I squared in your final solution. All right, number 9 is another double distributing. So we have 10 plus 4i minus 15i minus 6i squared. Again, like terms, and replace your I squared. 10 minus 11i minus 6 times negative 1. So 10 minus 11i plus 6, which is really 16 minus 11i. Number 10, we've got 4 times 4 is 16, negative 12i, positive 12i, and negative 9i squared. Remember, I times I is I squared. Well, when I add these like terms together, negative 12 and positive 12 is just 0, so that's gone. I have 16 minus 9, but I never want to leave an I squared in there, so I know that's negative 1. So 16 plus 9 gives me 25. Okay, now something squared, this is equivalent to 4 plus 3i times itself. Remember, anything squared is multiplying it by itself. Okay, so now I'm going to distribute. 4 times 4 is 16, 4 times 3i is 12i, inner times inner is 12i, and last times last is 9i squared. All right, look for your like terms and your I squared. So 16 plus 24i plus 9 times negative 1. So 16 plus 24i minus 9, and that gives you 7 plus 24i. Now I'll give you a way to check your answer. So we talked about how do you check that? Well, 4 plus 3i, if you find the I button on your calculator and square it, there's your answer, 7 plus 24i. If you do this one, 4 plus 3i times 4 minus 3i. Okay, I just keep the parentheses as is. You know that the I is above your decimal, right? It's just right above the decimal. So you hit second decimal, and then there's your answer of 25. So if you want to use your calculator to check your answers, that's great. It's a way to make sure you have the right answer. All right, this is solving exactly like what we did yesterday, except you might get imaginary solutions. So there is an equation, there's an equal sign. You want to isolate the x squared. Once this is all by itself, to undo it, you take the square root. So I've got x equals, since I need two solutions, I know it's going to be plus or minus. But now what's the square root of negative 81? Right, it's 9i. The reason for that is you got square root of negative 1 times square root of 81. That's I times 9 9i. So your answer is plus or minus 9i. All right, this one I need to undo the 81 by subtracting. So I have 3x squared equals negative 81. Then I'm going to divide by 3. X squared equals negative 27. All right, if I take the square root of negative 27, this gives me a decimal. So I know that I need to simplify my radical. Remember, when you take the square root, I know I'm going to have plus or minus. I could tell right away I'm going to have something with an I. And what's a number that goes into 27 that's a perfect square? Well, we have 9 times 3. So square root of 9 is 3 root 3. This square root of negative 1 just means that I have 3i radical 3. If you want to, you could double check that this is the correct answer. So we can say, well, 3i radical 3, and that's what we got. Okay? So make sure your answer doesn't have any decimals in it. They should all be simplified radicals. And if you're taking the square root of a negative, make sure that you have an I in your answer. And we know we should have plus or minus because we did that yesterday. All right, I need to undo the negative 3. So I have x squared equals negative 9. To undo the square, I square root. And then that's a perfect square, so I know that square root of 9 is 3. But I'll have an I, so it's 3i. And I know I have to have two solutions, so it's plus and minus 3i. Okay, last problem. I'm going to subtract the 8. And I have 1/2 x equals negative 8. Now, if I do negative 8 divided by a half, you either have to put it in parentheses or divide by a fraction. Oops. Okay, so make sure you get negative 16 for this problem. So x squared is equal to negative 16, and I'm going to take my square root. So I know I'll have plus or minus. Anytime I take the square root of a negative, I know I'll have I in my answer. And what's the square root of 16? It's 4, so it's plus or minus 4i. Okay, so again, use your calculator to your advantage. If you want to do what's the square root of negative 16, and if that helps you remember that there's an I in it, that's perfect. The only thing your calculator will never show you is it won't show you the plus or minus, so you have to remember that. So if you can remember that there's always two solutions, that'll help you remember to put the plus and the minus down next to your answer.